Hello everyone and welcome back. My name is Mr. Koval, and in this video we're going to talk about polyprotic acids. So let's get into this. What is a polyprotic acid? A polyprotic acid, as the name indicates, poly meaning many and protic referring to proton or H plus. So a polyprotic acid is an acid that has more than one acidic proton or H plus that can be successively ionized. So here we have a couple of examples. We have our sulfurous acid here, H2SO3, and we have phosphoric acid, H3PO4. Each of these hydrogens here can be released, and so this is a polyprotic acid. Here we have three hydrogens that can come off, and here we have two hydrogens that can come off. So when you're talking about polyprotic acids, the hydrogens come off. Typically, they ionize in successive steps where each step has its own Ka value. So here we have an example of using H2SO3. So the first hydrogen is going to come off. So we have H2SO3 is going to react with water. One of the hydrogens comes off to form the hydronium ion, and then you have the anion that's left over, HSO3 minus. And so that has a Ka value. So that first proton, that has a Ka value of 1.6 times 10 to the negative 2. So this is the ionization constant for that first proton. Now the second proton will come off next, and so this will now release another proton. So it's going to react with water. So this hydrogen will bind to the water, be transferred to the water. Now we get another hydronium ion, and then we get our SO3 2 minus anion as a result. And so you'll notice that this also has its own Ka value. So it has an acid ionization constant of 6.4 times 10 to the negative 8. Now, one thing to note here is that you'll notice that the second hydrogen, the second proton to come off, that has a much lower Ka value compared to the first one, and that is typically the case. So when you have successive hydrogens coming off of your polyprotic acid, the first hydrogen come off is much more strongly, much more readily to be removed than, say, the second or third ion from, or third hydrogen from the polyprotic acid. And so your Ka values will typically get smaller for successive ionizations. And because of this, you can typically ignore the H plus formed after the first ionization because the ionization constant, the acid ionization constant for those second and third H's or H pluses is going to be so low that it's not going to be much of a factor, and it could be ignored. Also, on top of that, we can typically ignore this because, again, because of Le Chatelier's principle, the first hydrogen is coming off. That's going to kind of do an H plus dump into solution, and so that's going to be going to cause this reaction to be more suppressed, because when you're increasing the amount of H plus from the first ionization, that's going to cause this equilibrium to go more towards this way, towards the formation of the HSO3 minus. So HSO3 minus is going to be even less likely to give off a hydrogen. So because of that, when we calculate pHs of polyprotic acids, we can typically just ignore the other hydrogens that come off and just deal with the first hydrogen and treat this like a monoprotic acid, and just use the first Ka value to figure out the H plus concentration, and then from there figure out the pH. And so we could treat this like a weak acid problem where it's just a monoprotic acid. The only time that this would not be the case is when it is a very dilute solution. So if you have a very dilute solution of, say, for example, H2SO3, then you will have to take in consideration the second ion, as well as the hydrogen from the auto ionization of water, right? So that's another thing you need to be aware of. So I hope this is helpful. If you enjoyed this video, if this helped clear up some things about polyprotic acids, please make sure that you uh, like my video right down here, hit that button there. Also, you might want to hit that notification bell for other videos I put out. Make sure you subscribe to my channel and put a comment down in the comment section below. Let me know what you think. Let me know if you have any questions. Thanks for joining me. Have a great day.